Hello everybody, Dr. Patterson again. In this video I'm going to walk through the lab tasks and actually solve them myself. This particular video will be the Matlab version. So if you want to see how I did part of it, there's just going to be three sections to the video for each of the lab tasks, and those you probably downloaded by now, but if you have not, again, I recommend you doing them first before you watch this video. But we're going to walk through these three tasks and then try to make them work on the board that we've set up. And that's, again, in the previous video, I walked through how to wire everything up. So back in Matlab, the first thing I'm going to do is set up a new folder. So new folder, I'm going to say week 1. And I'm going to drag that previous code that I had just to test the lab setup into week 1. And then I'm going to double click on there. And whatever folder is your current folder will be your current working directory. And so if you try to run a file from another folder, you can do that by adding it to the path. And Matlab will always ask you if you're trying to run a file from another location, if you want to add it to your path. I find for something like this, where we're doing specific tasks in a given time frame that are all connected together, making it its own folder and giving it a name like week 1, because everything is in week 1, can help you stay organized. There's been a lot of times in the past where I've had students that literally have a 1301 folder, and over the course of the 10 weeks, they just compile all of the programs that they've written. And then when they want to show me something, it takes them 5 to 10 minutes to figure out which file that they're actually trying to show me. So back in Matlab, we're going to create a new script. And I'm going to start by clearing everything out. So clear all CLC and INSTR reset, just to make sure it clears out previous serial connections, kind of guaranteeing that it'll work each time. And then if we go over to the lab tasks, the first one is turn an LED on when one button is pressed and turn the LED off when the second button is pressed. So if we go back to Matlab, the first thing that we need to do, and I'll go to the documentation page first. If you don't remember the Arduino, there it is. The Arduino class is what we're using. We're creating an instance of that class, and it's passing back that particular object, which we're able to reference functions as a part of that, like essentially on that object, called methods. So we can say let's say my Arduino object is equal to Arduino, and that'll make the connection, which is great. And I'm going to put a semicolon at the end because I'm confident that that line of code is going to work. And then we wanted to, again, going back to the task, when a button is pressed, turn an LED on when the button is pressed and off when the other button is pressed. Okay. A little more complex than I said the first time. So we can think about how we want to set this up. And I'm actually going to pause for a second and get my writing tablet up. And so the circuit that we set up, I had the 2 buttons and then the LEDs down here. And what we want to do is we want to say, just reading off the text, right? Turn an LED on when one button is pressed. Turn the LED off when the second button is pressed. And so if we go back and we think about that just from without writing any code, what do we need it to do? If we'll call them button 1 and button 2, right? So if button 1 is pressed, then we're going to turn an LED on. Right? And if the other button is pressed, then we turn it off. And so just laying out the logic ahead of time instead of trying to just jump into the code can help you think through like setting up your different statements. Like what do I need what do I need to happen in this program? And it's just a simple check. If the button is pressed, we do one thing. If the other button is pressed, we do the other thing. The only troubling thing right now is that if we write this like this, it's going to go through this code and it's going to do it one time. And so what we want it to do, it doesn't specify an amount of time. So we want this to go forever, effectively. And the way we can do that is having a while loop that encompasses the whole thing. And we always want to be in that while loop. And so there's two ways you can think about it. One, you could use a comparison that's always true. You could say 1 is greater than 0. That will always be true, right? And at the very end, we can say end. And so it'll stay in there. Alternatively, Matlab has logicals. And so we could literally say, while true, do that. And that's part of the instrument control toolbox, I believe it is, the logic statement. So we can put true in here, and it actually provides that logical 1. Or if we say false, it provides a 0 value. So we don't necessarily need to perform the comparison because that's what's being passed back when we do these is 1 greater than 0, right? Is 1 greater than 0. Oops, not A. Is 1 greater than 0. It provides that logical 1. And so instead of actually using the comparison, we can just say true or false. Most of you are probably familiar, from what I've seen in the past, most of you are probably familiar with this. So we'll stay here. We'll keep that, and then I'll just put a semicolon, or sorry, a percent, and could also put true, right? And then we'll close out that loop at the end. And what we want to put in here is those two if statements. And so we want to say, if button 1 is pressed, turn the LED on. So going back to the loop, we can say if, and what do we need for actually getting that value? Well, if we go back to the Matlab documentation page, there's read digital pin. And we're using that method on the Arduino object, in this case, my Arduino object. And I'm saying if my Arduino object, and I'm saying, hey, board, read that pin. And I'm telling which pin to read. I'll say pin 2 in this case. If that comes back as a 1, a true statement, then we can go into that statement, that if statement. It passes back a 0 or a 1, the logical value. And so you don't need to have a comparison. I could say if it's equal to 1. But I don't need that. Just like I didn't need is 1 greater than 0, right? And so what I'm going to do is I'm just going to leave it as that, because if it comes back as 1, that means it's true. It's going to go into that if statement. And so when we're in here, then we can tell it, all right, turn on the LED. And so I can say, well, the other command for that was write digital pin. And I need to say, hey, Arduino, the connection that I'm made to the board over here, I want you to write to a digital pin, and I want to specify a certain value. So I'm going to say my Arduino object right digital pin and pass it. I'm going to use the first LED, pin 4. And I'm going to pass it a value of 1 because I want it to turn on. And that's actually all I need, right? So the first time I press this button, it should turn the LED on. And we can test that. You'll have to save it. I'm going to call this lab task demo. Should have called it demo 1. So nothing's happening right now, but then when I go over here and push this first button, that LED turns on. It doesn't turn off, unfortunately, no matter what I do. That's the other half. That's the other if statement I need to do. So I'm going to come back to Matlab, and I'm going to, in the command window, click and then press Control-C and stop the program from running. And then I'm going to include that other if statement. I could do an else if. I'm just going to put another if statement down here and have it check pin 3 and then say again for pin 4, but I want to write a value of 0. So I can save this. And you might have noticed I wasn't actually getting any printouts from this program. The only ones that would provide a printout would be this Arduino line, the read digital pins, which is actually using that value in the if statement. And so those don't show up. And then there's no value passed back from the right digital pin. And so nothing's being written to the command window. So we can run through this again, assuming I don't have typos. So it's operating, so I can turn on the LED and then press the other one and turn it off. On, off, on, off. The only downfall of this relatively simple program is if I hold both of them down, it's going to turn on and off really quickly. But I didn't say it couldn't do that, right? That's it for task 1. So we'll call that good on task 1. We can come back to command window and hit Control-C. I'm going to create a new program. So we'll say new script. And I'll grab those first few lines again. We're going to be starting it the same way. So the first line is clearing everything out. Third line is creating a new instance of the Arduino class with a connection to the board that's sitting on my desk. And so we can go down and then look at the other lab task. We've got turn on LEDs one at a time by incrementing or decrementing which LED is addressed. And so I should see these blink on one at a time, continuing up through there. And then in theory, what does it say? I came up with these and I still have to read them. Users should be able to press either button in the middle. Following transitions have an impact the LED direction. If one button is pressed, it should go up one at a time and turn on for a second, and then stay on at 9. And then it should do the opposite, going twice as fast back down to 4. Seems easy enough. So what we can do, if you watch my other video, I use the modulus. I think I might do that again. But we needed to monitor the 2 buttons again. And really, we only wanted to change. There's 2 ways we can do this. One is by like having it be like I need to only press a button during a specific time. What I'm going to do instead is I want it to constantly monitor the button and then change the LED when it's actually time. So what we can do is think about how we could increment or decrement in the same way. And one way to do it would be if we have some value that's either +1 or -1. And so if we press a button, we could set the, here, let's write it out. So if we'll say button 1, and I'm just gonna use that as is pressed, right? Let's write it out actually. Is pressed. Increment equals +1. Else if button 2 is pressed, then increment will be equal to -1. And so when I press one button, it'll start counting upwards. And when I press another button, it'll start counting downwards. It's got a different time in there as well. So what I could do, it's a good way to do this. We could try to be fancy and combine it. Or we could store a second variable with the amount of time. So it's 0.5 seconds. Let's do it this slightly fancy way. So let's say minus 0.5. And I'll show you why. So it's definitely in the negative direction, but we're going to use something called the floor function, which is essentially just rounding down all the time to round that down and decrement a full value oh no, is this a good idea? We could then use the absolute value. Totally inefficient. Let's do it. So we've got those two buttons monitored. We've now got an increment value and a time value stored in a single variable, which we're going to use. And then we need that to actually go in and say, change the pin value. So after that happens, then we want it to only do it after a set amount of time. So what's a good way to do that? We could say we want to track a previous time. The reason we don't want to just say pause for a second, right, is that if we did that, then when I press the button, it's not going to even be able to read the button. Let's program it that way, and I'll show you like why this is a bad idea. So if we say, if I can find my mouse, there it is. We'll do a while true again. And in there, I'll say if, and we'll use the my Arduino object dot read digital pin, and we'll read from pin D2. And then we'll say else if my Arduino object dot read digital pin, and we'll say D3, and then we'll end there. Not every language is the same. And so in here, I just want to have some value. Let's say increment is equal to, we'll start with 1. In here, I want to change it to equals 1. And right here, I want to say increment equals -0.5. And so now I've got my increment. And if I said wait that amount of time, if I said pause for absolute of increment, so now you see how I'm getting my delay. I'm either going to have a 1 second delay or half a second delay. And then I could say, well, what I want to do is I want to grab the next pin. So I need to know which pin to address. And I need to turn the LED on. Let's say determine LED. And then turn on LED, pause for a little bit, turn off LED. And it doesn't say I need to pause for the off time. So we can leave that as is. I don't want to complicate it further. So we need to determine which LED to turn on the LED, wait for a little bit, and then turn it off. So we need to store somewhere what the current LED pin number is. And we can say LED pin, and let's start, because we're incrementing upwards, let's start with 4 because that's the first LED that I've got. LED pin equals 4. And what I can do is then say, well, determine the LED. I can say LED pin equals LED pin plus floor of increment. And if I were to show you what that does, well, floor of 1 equals 1, because anytime you round an integer number, you're going to get that integer number. But if we were to say floor even 0.99, you get 0. So it rounds anything below that down to the lower number. Just like if I say floor negative 0.5, I get negative 1. So we're rounding down if we need to, or just staying at 1. And then we're pausing for that increment, and then we're going to turn off that. So we didn't turn on the LED yet. So we can say, hey, Arduino, write digital pin, and pass it the pin number, which is just the letter D as a string, so the double quotes, and then add the number, the LED pin, and then pass it the value that we want it to go to, which is we want it to be on. And then afterwards, we want that same LED to turn off. Now, you may or may not have noticed there's problems with how I'm determining this LED pin, right? And one of them is that if I'm counting upwards, nothing stops me at 9. I could just keep going. Just like if I'm counting downwards, nothing would stop me from going lower than 4. I don't know if Matlab has a... So there's other languages that it's called a clamp function. Let's see if they have it. No. What another name for that is. What we can do instead is do an approach that uses the min-max value. So we can say LED pin, we're going to modify it one more time, and we don't ever want it to go below 4. And so we want to say equals max 4 comma LED pin. And so if it ever goes below 4, it will pick 4 because that's the maximum value, right? And then we can think about that. Well, that's good because then we never go below 4. But we also want to do the same thing about never going above 9. And so instead of this LED pin argument, I'm going to put a min function in there, and I'm going to say the minimum between 9 and LED pin. And so now that minimum function is saying, don't ever go above 9. If you're ever above 9, I'm going to pick the lower value, which is 9. And the max function, which it's all sitting inside of, is saying, if you ever go below 4, I'm always going to pick 4. It helps a little bit, but this still allows the LED to blink if we've gotten to that value, which we'll be able to fix in a little bit. So we're going to do this, and so we read the pin, we set the increment value, and then we blink the LED, right? So this is going to kind of work. So let's save and say lab task 2. And we can run it. So it should start blinking upwards. Oh, it's not turning them off. Oh, because I put a 1. Let's change that to a 0. Let's run that again. So 1 at a time, it's blinking upwards. And then when it gets to 9, it's actually blinking on and off, but it does so very quickly. It says it's supposed to... Button is pressed. Keep 9 on. So technically this is not correct yet. So we can say if it's a value of 4 or 9, don't turn it off. Well, that's problematic too, because the other ones, we need to turn it off when we leave. Well, let's change direction to make sure that part works first. So it's going back down and it's twice as fast. That's great. And if I press it, you see the first time it didn't work. And that's because I pressed it during that half-second delay. And if I wait for this one, I can like time the button press so that I can guarantee it won't work. If I hold it, it'll go back down. And so we're going through there and constantly waiting, which means we can't update the button value. And so what we need to do is adjust how we're doing this. So this is, I'm not going to finish this one out because this is already broken, right? The logic for this is broken. So what we need to do is figure out a way to use time to hopefully accurately monitor the button press and also time those LEDs. So if you're not familiar, the tick and tock commands, if I were to go down here and stop the program, if I type in tick and then wait a few seconds and then type in tock, it tells me exactly how much time has elapsed since I issued the tick command. And so we can do that again. I can say tock and even more time has passed. And if I keep pontificating, I could go on for, I mean, I've gone on for upwards of 50 minutes, which is a lecture. So we can use a timer to actually try to monitor the LED for when it should turn on or turn off. So the way we could do that, we could say we need a way to track it. So out here, let's even say within here, we need a way to track the previous time that it was issued. So let's start the timer out here and then say tock is, initial time. Or even better yet, previous time is equal to tock. And so what that does now, just like if I come down here and say tock, or if I said previous time is equal to tock, it sets that value equal to that variable. And so now in previous time, I have exactly the amount of time that's elapsed. So I can come down here. We've got a way to determine which LED is next. That's helpful. But we probably don't even want to do that unless we have elapsed the correct amount of time. And so what we want to do is say, I'm going to get rid of this pause because that's not going to help us. If previous time is less than, previous time plus absolute of the increment is less than tock. And what that's doing is saying the previous time, whenever I last modified an LED is how I'm going to use it, then plus that increment. So initially when it starts, it'd be like, well, that's 1 second from now. So after the talk timer has elapsed past that point, then it'll go back into this if statement. So we can say first we want to recapture that a new previous time. And so now it's only going to go in there every increment. And we could even test that. Let's comment out all this stuff and have it print out the new previous time value. So 1 second, 2 seconds, it's slightly more than 1 second because one, the timer it's not perfectly going to land on those values. And also those read digital pin commands take time. And so we're unlikely to ever perfectly land on 1 second. And we could even say, let's comment that out and see how much time is actually elapsing each time. So talk minus previous time and see what that is. It's going to be a little over 1 second every single time. And if I push that other button, so just over 1, yeah, so it's like hundredths or thousandths of a second over. If I push the other button, it immediately goes to the half-second delay. Just like when I push the 1 second, almost immediate response to switching the increment, which is exactly the behavior that we were looking for, is we can switch it right when that button presses. And so it's going through that loop a bunch of times, just checking the buttons and also checking what time it is. And so now in this loop, this is when we can turn an LED on or off. So the first thing we can do, we want to figure out what that LED time is, or sorry, what the LED pin is. So we can grab the code that we wrote earlier. And we want to set the previous LED off. We also have to keep in mind that we don't want to blink LED 4 and 9 on and off, but maybe we'll come back to that part in a little bit. So right now, we would want to make sure the previous LED turns off and then the next one turns on, right? And so we can grab the one that turns it off. And before I change the LED pin value, I'm going to turn the LED pin value off. And then I'm going to turn the new one on. And so I think this will work just as before. If I can stop my other code. So let's run this new one and see what happens. It's counting upwards, that's good. And it stays there. It is blinking still, but then if I press the button, it immediately responds and goes back down. Immediate response to go back up. So the main behavior is good. It checks out. I just need to check if the pin is 4 and we've got an increment that is negative, don't turn the LED off. Or if it's 9 and the increment is positive, don't turn the LED off, because we don't want those LEDs. It's kind of hard. It might be kind of hard to see in the video, but this is blinking just very quickly. So just like I said, I'm going to say if LED pin is equal to 4 and increment is less than 0, then I don't want it to do anything. So we can put that into parentheses. And that's one case. The other case is or if LED pin is equal to 9 and the increment is greater than 0, then what I'm going to do right here is otherwise I will turn on the LED pin. So I'm going to have the code do absolutely nothing in the 1 and then otherwise turn that LED pin off. In theory, I could also throw this new LED pin check in there, but I'm just going to leave it simple. I'm just going to not turn the LED off each time. I'm even going to let it turn it back on, even though it's already on. It won't change the value. So let's go down here and close or cancel that program and then run this one. See if it works. So it's incrementing upwards and it stays on. Let's see if the button works. All the way down, it stays on. Does it go back up? All right. I think that's everything that I was asking for is, I didn't think it was going to be that complex. Should have tried it before I finalized it. Turn the LEDs on one at a time by going up or going down. You should be able to press the button in the middle. Let's test that. Hey, that works. So I don't have to wait for it to go all the way to one side. If it's pressed, it switches direction and they stay on. Cool. All right, the last one is when one button is pressed, play the Matlab gong sound. When the other button is pressed, play the handle or handle, or however you pronounce it, audio data. Allow users to continue to press either button. And I even give you a hint here, the sound SC. So if we go over to Matlab documentation, I type in sound SC, there's a way to play sounds, and there are built-in sounds in Matlab, specifically in matrix format. And one of them is gong.mat, and then you can play it. So let's try that real quick. Let me turn on my audio so you can hear it. Stop my program. And then the other one is that's the chipmunk version of that one. There it is. All right, so we're going to play those two just by pressing the buttons. And so this is mainly just focusing on, like, you don't have to have everything happen on the Arduino. You can have certain things happen on your computer if you want to. So let's do a new script here. Just click the plus button and we can grab those first few lines because we're going to do the exact same thing. And then in this loop, and we can even come back to one note here, and I'm just gonna grab, we're gonna use the same logic setup, and I'm gonna say if button 1 is pressed, play the gong. Otherwise, play handle. Seems easy. The only thing we need here is a while true loop with an end at the end. So let's go back to Matlab and type that one out. So while true, again, you could write 1 equals 1 or 1 is greater than 0 or whatever other true logical statement you want. And in here, we want to have that same loop where the same if statements where we're checking for the button presses. So if my Arduino object dot read digital pin, and pass it pin D2. We used else if, which is one word in Matlab apparently. My Arduino object dot read digital pin is D3. And in this one, the load allows you to load both separately. I hate to load the sound every time. Normally it tells you more about the functions that are used on that particular page. I was looking for something that would tell me about load. Let's click on, nope. Some of them are links, some of them are not. Disappointed that they're not. So I'm gonna see why. Yeah, it loads it in as a Y. Wonder if we can just, wonder if we said, nope. Just guessing. Load variables. Let's see what the info on this is. Load file name. Loads it into the workspace. Load a specific variable. Oh, here we go. So at the beginning, I'm going to say gong sound is equal to, I can say, using the same idea here, right? Handle.mat, and I'll even grab this and bring it over as the example. So we can say, I need to use that same structure. And so I'm going to say load, and then in this case, I'll say gong.mat. Can't type tonight, apparently. And then I will pass it the gong sound. And so if I load this now, if we watch the right-hand side, gong sound not found. What do I need here? Oh, you can also, oh, if it already contains the variable. What if I do it the other way? Load gong.mat. Why would it already need to exist? That's so goofy. Shame. Should get one of those loud bells. It should not be that way. So let's initialize the variable and see if that. No. It says no. Just load it. I'm mad at this, so I'm gonna pause and figure this out. I'm a little embarrassed. I was trying to load gong sound from the matrix that was stored as a file. So I figured out the way to do it. So what we can say is almost exactly what I tried to do initially. Is we're going to take this and say this. get rid of this. So we're going to load gong.mat. And then if I want to play that, all I have to say is sound sc, and then I can put gong sound.y, and it'll play that sound. Just like if I wanted handle music is equal to load, and then handle.mat. A little disappointed. I used to know how to pronounce that guy's name. Sound sc handle music.y and play that one. And then we can save this one as lab task 3. And then we can play it. Let me turn on my sound so you can really hear it. Better turn that down. But the real test is, can I make this play? And I'm going to turn on my, give me a second. Let me verify that you can hear this. All right, just in case you couldn't hear it, cover your ears. Oh, mad echo. So that's it for these ones. Hopefully you find this as funny as I do. That's why I always put this one in here. So that's all 3 lab tasks in Matlab. I won't be able to do everything in C because I'm not going to jump into the serial communication needed to communicate back to Matlab so that we can play the audio. But I'll do those first 2 tasks in C, and then hopefully if we have time in Python as well. So that's all I've got for this one. See you in the next video.